Hello, welcome to Prajim Technologies. I am Venkat. This is part 21, Inheritance in C Sharp. In this session, we will learn why inheritance, advantages of inheritance, inheritance syntax, and a few concepts related to inheritance. So let's first look at an example of why we actually require inheritance. Now, if you look at these two classes on the slide, we have full-time employee and part-time employee, two types of employees working within our organization. Now, whether if he is a full-time or a part-time employee, there are certain things that are common to them, like first name, last name, email, and calculating and printing the full name of that employee. Most of this code is actually common between these two classes. If you look at these two classes, there's a slight difference. For a full-time employee, we have yearly salary, whereas for a part-time employee, we have hourly rate. So now that's the only difference, basic difference between these two classes. In reality, there might be several differences, but just to illustrate, why we might have to use inheritance, let's take this example. So the difference between these two classes is that, you know, this employee has an yearly salary field, whereas part-time employee has an hourly rate um, field. Okay, so these two classes, instead of duplicating a lot of these this code between these two classes, what we can actually do is we can abstract away most of the common code into the base class as you see here. Now, what is the advantage of doing this? Number one, you get code reuse. And when you get code reuse, the amount of code the testing team has to test is drastically reduced, and the amount of code that is there in the application is also reduced, because of which the probability of errors within that code is also reduced. So it could save a lot of time, as well as it could also prevent from unwanted errors within the application. So inheritance promotes reusability, and with that we get savings of time, and the probability of less number of errors. It also reduces errors. Okay, so if you look at this, we actually have rewritten this class, all the common functionalities in the base class right now, and basically whatever are specific to full-time employee or part-time employee, they are only present in that respective classes. So in our example, only year salary was specific to full-time employee, and hourly rate was specific to part-time employee. So these class specific code is present in those respective classes, whereas the common code is abstracted away into the base class so that it can be reused across these two derived classes. Now let's go ahead and look at an example of how to do this. Okay, so if I have to create an employee, you know class, public class, this is going to be our base class, public class employee. And in this base class, we are going to have all our common properties like first name, last name, email, and then full name. So public string first name, and similarly we'll have his last name and maybe email. Actually, let's get rid of the public access modifier. For fields, it's not a good habit to have public access modifier. When we talk about properties, we'll come to know why. So string email. So these are common to both full-time employee and part-time employee. So print full name. So basically all this piece of code is common to both type of employees. Now let's say I'm going to create our full-time employee. So full-time employee, and this person is going to inherit from the employee class. Now this is the syntax for inheritance: your base class, your derived class colon your base class. So now what happens, whatever is present in this employee class will also be available to your derived class. Okay, so basically, these fields are private now at the moment, but since if they are public, they will be available to your class. We'll look at those a little while later. We create fields, and then surrounding them we actually create properties so that they will be available to your derived class. So similarly here, what is specific to A full-time employee may be an yearly salary, so float yearly salary. And similarly, I can go ahead and create a part-time employee class. So part-time employee class inheriting from the employee. Now this piece of code again will be available to this class, and then this part-time employee may have something like hourly rate. Hourly rate. For now, let's make this public so these are available to, but keep in mind making your fields public is not at all suggested in real time. Instead, we make our fields private and expose those private fields to the external world using properties, which we'll be looking at in a later session. So similarly, let's make this public and this public. We will be talking about access modifiers as well in a later session. Here, the idea is to learn about inheritance. So let's concentrate on that concept. Okay, so now we have created full-time employee, part-time employee. Now I can go ahead and create my full-time employee. So full-time employee FTE is equal to new full-time employee. Now look at this full-time employee object, it doesn't have the print full name method, or it doesn't have first name last name properties, but still I will be able to use them. So for example, FTE dot, you know you can basically say first name is equal to maybe Prajim, and similarly we can say FTE dot last name is equal to tech. So I'm able to initialize that object with these two properties, in spite of that code for a full-time employee not present here. Since this class is inheriting from the employee class, all these will be available to your full-time employee. So similarly, I can go ahead and call the print full name method as well. And even that property is not present in this class. I mean, that method is not present in this class. And the employee, full-time employee specific field, which is yearly salary. So yearly salary is equal to whatever, maybe 50,000, 500,000, whatever. Okay, now look at this. On the other hand, you will not have access to hourly rate because that field is specific to part-time employee. And if you look at here, we are creating an object of full-time employee. So your full-time employee object will have access to all the code that's present in the base class plus whatever code specific here. So in a way, we can say this full-time employee class is actually a specialization of your employee class. In the sense, it has all the capabilities of your base class plus additional capability that is present in that class. So your derived class is actually a specialization of your base class. I mean, we can compare this to like, a general surgeon versus a specialized doctor. For example, if you take, maybe a gynecologist, she'll be able to perform the duties of a general surgeon as well as she is specialized in gynecology. So at times she can even behave as a general surgeon. Okay, so that's kind of basically the difference between a parent and a derived class. So now we don't have any implementation here, but if you want some implementation, we have seen in the other examples, if we want to print the full name, we can make use of the console class to write line, and we can say first name plus, and then give a space, and maybe last name. Okay, so now if we go ahead and run this, you will see obviously a full-time employee object is created and its first and last name is printed there. Similarly, I mean, if you want to create a part-time employee, you can exactly do the same thing. And whatever is present in your base class is actually available to your part-time employee as well. So part-time employee dot first name. So that's still available. So maybe we will call this part, and similarly last name is equal to maybe time. And then if you look at this object will have access to hourly rate. From the IntelliSense, you can see that it has access to hourly rate, but not yearly salary, because yearly salary is specific to full-time employee. And similarly, we can also call the print full name. In this case, part-time will be printed. So presume tag from the full-time employee object, part-time from the part-time employee object. So basically, inheritance allows code reuse. So why inheritance? In object-oriented programming, we have four pillars: inheritance, encapsulation, abstraction, polymorphism, and inheritance is one of the primary pillars of object-oriented programming. Okay, several other concepts are actually based on inheritance. If you have to understand polymorphism, you need to understand inheritance properly. So that's the primary pillar of the object-oriented programming. It allows code reuse. We have just seen an example. And when we reuse code, it can reduce time and errors. And we have also seen that we'll specify all the common fields, properties, methods in the base class, which allows reusability. In the derived class, we will only have fields, properties, and methods that are specific to those respective derived classes. Okay, we have looked at an example of inheritance syntax as well. You'll have a parent class and the implementation of that, as you can see in the slide. And the derived class, you include a colon and then specify the parent class. We have seen that within our example. So here we have our derived class, for example, part-time employee, colon, employee, the parent class. Okay, in this example, derived class inherits from parent class. C# supports only single class inheritance. That's very important to understand. Okay, C# does not support multiple class inheritance, in the sense for your given class, you can only have one base class at a given point of time. I cannot specify another base class. Let's say, for example, this part-time employee class is inheriting from base employee class. Let's say I have another class, maybe public class A. This is another class. Now, can I make my part-time employee class inherit from employee class as well as, class A at the same time? This is not practical. If we try to build this, build solution, we will get an error. Cannot have multiple base classes. Part-time employee cannot have multiple. So remember, a class can have only one base class at a given time. But however, multi-level class inheritance is possible. For example, part-time employee is inheriting from employee class. So you can say class A inherit from part-time employee class. Now, this class A will have all the properties, all the code that's available in part-time employee, plus the code that's available in employee. So if somebody now goes ahead and creates an A object, so let's say A1 is equal to new A. Now what happens? A1 will have access to everything that's available in part-time employee as well as employee. So in part-time employee, we have hourly rate. In employee, we have the rest of the properties, as you can see them. So multiple class inheritance at the same time is not possible, but multi-level class inheritance is possible. Class A inheriting from class B and class C inherit from class A maybe. So the multi-level class inheritance is possible. Okay, but remember, C# supports multiple interface inheritance at the same time. But we haven't spoken about interfaces yet. Probably we'll cover that in a later session, but just I want to bring that point here so that it's there in the back of your minds. But we'll do an example of that when we actually talk about interfaces. So remember, C# doesn't support multiple class inheritance, but it supports multiple interface inheritance. Okay, and another point to keep in mind is child class is a specialization of base class, which we have already seen. Our part-time employee, full-time employee, is actually a specialization of our employee class, in the sense it can do everything that your base class can do, plus whatever is specific in that class. So in a way, it's a specialization of the parent class. Okay, base classes are automatically instantiated before derived classes, and this is another important concept to actually understand. Let's get rid of this one. So anytime we create an instance of a child class, okay, here full-time employee is a child class. So anytime we create an instance of this child class, it automatically creates an instance of base class. In the sense, before the child class constructor gets executed, before the child class constructor gets executed, the base class constructor will be automatically executed. And it makes sense because look at this. This print full name is actually an instance method. Now, if you are new to methods and if you are new to understanding this difference between static and instance methods, please refer to my previous video tutorials. We have discussed that there. Okay. Now, here print full name is actually an instance method which is defined in our employee class. Now, if you have to invoke an instance method, we know that we need to have an instance of that class. So obviously, and this print full name is actually present in the parent class. And if you look at the main method, what we are doing here is actually creating an object of type full-time employee, the derived class. We are not creating an instance of the parent class, but print full name is present in the parent employee class. So if that method has to be available for this object, then that class needs to be instantiated even before we can create an object of this class. Okay, so when you try to create an instance of your child class, the parent class gets instantiated even before that. So parent class constructors are called before child class constructors. Let's actually look at a simple example of that so that it makes sense. So let's get rid of all this code. I mean, in terms of just looking at it as a parent class and a base class. So public class, parent class. Okay. And let's say public parent class. And we'll say console.writeLine parent class constructor called. Okay, so if you look at this, we have a parent class and it has a parent class constructor. Similarly, we can say public class child class inheriting from parent class, and we can have a child class constructor, so obviously public child class. And probably we can say copy paste that there. And if you look at this, child class constructor call. Now if you look at this code, it's pretty simple. We have a parent class, a constructor within that, child class, a constructor within that. And now if we go ahead and create an object of child class, so child class cc is equal to new child class. We are only doing that. So we are creating an object of the child class. But look at this. We know the fact that before child class objects are created, parent class objects gets created. So obviously parent class constructor needs to be called. So when I go ahead and run that, you see that parent class constructor call, child class constructor call. Though we are not explicitly calling parent class, though we are explicitly not creating parent class object. Okay. On the other hand, let's say for example in the parent class I have another constructor, and remember we can overload constructors. We have seen this as well in our previous video sessions. So let's overload a constructor. Maybe I want to pass in something like a string data type. So string message. Okay. Now console.writeLine, all we have to do is let's print that message. Okay, now if you look at this one, the parent class has two constructors. Okay, one which takes parameter and the other one which doesn't take the parameter. Now when I go ahead and create this child class object, obviously we know that parent class constructors are called, but which one of them will be called? By default the parameter less one will be called, which means this constructor will be called. Let's go ahead and run that. So parent class constructor call, which is the parameterless constructor. But on the other hand, let's say when I create a child class object, okay, when I create this child class object, I always want to make sure this constructor gets called. So I pass in a message, and that message can be used to initialize some of the fields in the parent class. So how do I ensure that the constructor of my choice in the parent class gets called when I create a child class object? So how can we do that? That you can actually control using the base keyword. So base, and then look at that. Your parent class, so base keyword refers to your parent class. So we know that in the parent class there are two constructors, and the IntelliSense clearly shows that one constructor without parameters, another constructor with the message. And now you can pass whatever message you want here. For example, let us say message from, or derived class controlling parent class. Okay, basically from the derived class we are controlling which constructor gets called when an instance of this parent class gets created. Okay, so now when I go ahead and run this, instead of this constructor getting called, this constructor gets called, and it and uh, and this message gets passed into this constructor, and that message is printed, and next the child constructor call will appear. So derived class controlling parent class, child class constructor call. Okay, so it's also possible that for the derived classes to control which constructors get called when parent class objects are created. Okay, so here you can find additional resources for C# and ASP.NET interview questions. Thank you for listening. Have a great day.